School of Environmental Sciences, Jawaharlal Nehru University works under the aegis of Ministry of Environment, Forest and Climate Change as the Environment Information Awareness, Capacity Building and Livelihood Program Center for carrying out various awareness activities under Mission Life. Mission Life stands for Lifestyle for Environment. This body, EIACP, functions with the agenda of integrating countrywide efforts towards environmental conservation and management. Now, let me tell you about the members who are present amidst us. We are privileged to have Professor Paul Raj, R, EIACP Coordinator, School of Environmental Sciences, JNU. We also have amidst us Dr. Sangeeta Goyal, Ma'am, Program Officer, JNU-EIACP RT. Then we are privileged to have Dr. Akanksha Kasania, Information Officer, JNU-EIACP RT. Ms. Ravina Bisht, ITGIS Officer, JNU-EIACP RT. Ms. Ruchika. Let us welcome them with a thunderous round of applause. Children. We also have the pleasure of the company of members from INYAS-NCR. INYAS stands for Indian Young Academy of Science. We have Dr. Ashwini Kumar Tiwari, Faculty, School of Environmental Sciences, JNU. Then we have Dr. Raj Mukhopadhyay, ICAR, Central Soil Salinity Research Institute, Karnal, Haryana. Then we have Dr. Pankaj Kumar, IUAC, New Delhi. And last but not the least, Dr. Subhash Babu. Alright, so let us welcome all our distinguished guests with a huge round of applause, children, once again. May I have the pleasure of inviting our principal, Shri Dilip Singh Sir, to extend a formal welcome to all our distinguished guests for today's occasion.
Good morning and Jai Hind, everybody present here. I believe all of you are aware of the present ongoing scenario of fossil fuel crisis in India, being most populous country, which is forced to impose certain restrictions, diversify and develop various other alternatives of fuels, and make the people aware where do we stand today, what would be our future tomorrow. Mainly the present scenario I am referring to the Iran and America conflict which is ongoing. Every day we all are hearing about that Hormuz Strait. One day it is opening, another day it is getting closed. And why do we listen all these things? Because we have dependency on fossil fuels, particularly the petroleum product. That is one of the source of energy. Like that, coal is another source of energy, which has its own negative and positive impacts in our life, had impact in past and will have impact in future also. Dear children, the way you look at the sky in the evening, if you would have experience of living in coal mines area or where you have thermal power plants, in that area if you look at the sky today, what we can do today to secure our future, our young generation, which is in the age of, say, 13, 14 years to the age of 16, 17 years today, when they will grow and they will reach to the age of, say, 50 or 60, how they would be breathing, how they would be walking, how comfort they will have in their life, whether they will have a real garden or a real tree existing around them somewhere to produce oxygen and absorb carbon dioxide. That's the matter of great concern for all of us. So, in this respect, we are honored to have the most important faculties from Jawaharlal Nehru University. Many of you may have dreamed to get admission into JNU. You must have heard name of JNU in various references. One of the most most important learning hub of our country. We are all officers of defense, those who are undergoing NDA training. During the training itself, they complete their graduation from JNU. And what not we can say about the JNU. So this is an opportunity for all of us to have with us a person like Professor Paul Rajmani, who is EIACP coordinator of JNU. And this program, which is in the partnership with the Ministry of Environment, Forest and Climate Change, and the term which I have referred, that is EIACP, refers to Environmental Information Awareness, Capacity Building and Livelihood Program, Center for carrying out various awareness activities. We are lucky to have our participation with this mission life, and life is lifestyle for environment. So I express my gratitude to all the members from JNU and maybe from Ministry of Environment or from other agencies like Indian Young Science Association. Now may I request, without taking much time, may I request Shraddha, our school captain, to pin up the badge to Dr. Paul Raj and formally welcome. Then I would request Ms. Ridhima Pandey to pin up the badge and welcome Dr. Sangeeta Goyal, Program Officer, JNU EIACP. Then I would request Smita Shukla to formally welcome Dr. Akansa Kasania, Information Officer from JNU. Then Surabhi, to welcome Madam Ravina Best, who is IT and GIS Officer from JNU. Then Anika Gautam, to welcome Madam Ruchika from JNU. And then I would request Janvi to pin up the badge and welcome Dr. Ashwini Kumar Tiwari, who has brought this entire team to AECS Narora, who is faculty from School of Environmental Science in JNU. Then I would request Diksha to welcome Dr. Raj Mukhopadhyay from ICAR, Central Soil Salinity Research Institute. And then Kashish, I would request Master Kashish to welcome Dr. Pankaj Kumar with the badge. And children, the most important thing today when we talk about the environment, I can share you one more experience with you all, and I believe many of you have experience. Like when you go to south, maybe some of you are from that side, or otherwise you must have visited our schools like Kalpakam or Kudankulam or Hyderabad, Mysore, all those, Kaiga, those areas. You must have visited place like Rawatbata, all rocky lands. You are living at present in place like Narora, which is located at the bank of river Ganga with lot of water. Using all resources, natural resources in an appropriate amount only gives you the real life. Wherever you make misuse of those resources or overuse of those resources, you may come across various environmental problems. In coastal area, there is high level of salinity in the environment. Place like Ganga, where you have lot of water, but overuse of water may spoil certain type of trees and plants, soil fertility, and the best example is why I have referred the place like Rawatbata where you don't have that kind of problem. But when people look at Rajasthan, people are still stuck at those pictures of 1960s and 70s where one lady putting an earthen pot on the head and holding the string of a camel and keep moving on sand dunes for say miles together in search of the water. Rajasthan is not like that. Why I am saying this? Because of overuse of water through Ganga Canal or Indira Gandhi Canal, the most fertile land of those 3-4 districts of Rajasthan where around the Pakistan border, that particular desert area where land, this canal has been extended when there was no water supply and people have started using water like anything for irrigation purpose. Water table has come up because of overuse of water on the surface. As a result, water evaporated and the salinity in the land increased. And thousands of hectares of land became permanently unusable for agriculture purpose. Who are responsible? We only people who are using excess water are responsible for that. Can anybody tell me the name of problem which is what particular name is given for that? this kind of problem of salinity in the soil, there is a specific term used somewhere, you must have studied in your social science, maybe in geography or, can anybody? Yes, from teacher side, anyone please? I have referred the place, area, okay, state, yes. That problem is given name same, SEM, same problem. So thousands of hectares of land has become completely saline because of excess salinity. Land has been spoiled permanently. Now nothing can be grown on that land. Why I am sharing this? We are living with enormous amount of water here. If we will make misuse of water, we may land to the same problem anywhere on the surface of land. And that's the reason there are lot of environmentalists like Professor Paul Ross and his team who are trying to instigate us, trying to make us aware that look at the future. What are the existing problems? What are the areas where we need to be aware of it, aware of all these things? And that's the reason we have targeted the students of class 9 to 12 who are grown up enough, who are able to understand, who are able to perceive their future very easily. So with these words, once again I thank the entire team of Professor Paul Ras for coming here, and I am sure this future generation, that when we are looking for Viksit Bharat by 2047, in another 20 years, they will be the working partners for our country, and we will be only the facilitators or guiding partners for our country. So they can contribute their best to our country, our environment. So thank you so much. Jai Hind.
Thank you, sir. It was indeed very informative welcome address, and thank you once again for shedding light on this serious and burning issue of environmental conservation. And I'm sure with collective efforts, we can surmount the challenge of protecting our environment. May I now request Dr. Pankaj Kumar sir and INYAS team to proceed for the lecture on physics and demonstration of Van de Graaff generator. I'm sorry, I beg your pardon. So I will now invite Professor Paul sir to briefly introduce about EIACP program.
Distinguished principal sir, vice principal, their teachers, organizers, their teachers and their students, my team members, ladies and gentlemen, it's a great honor to be this morning among you to say a few words about what is our EIACP stands and what is the role of it. I think, hope I am audible. Hello, students. Yeah. So now, as the principal sir has covered everything, our work is simple. This is what we do in a few, 5 minutes talk. He covered everything. I think I should take sir's help wherever we go. We should come with us because he covered everything. How many of you believe we have one more earth to live? Raise your hand. How many of you believe we have another earth in the universe to live on? Raise your hand. Good. What is your name? Ananya. Where is it? I asked, where is it? Do you have any earth or same planet Earth anywhere else? Come. Huh? Another universe. This, where? Another universe, this is a galaxy? Can we utilize that facility?
Hello.
Alright? A good guess. Anyway. So she's guessing that there may be another earth at the another universe. Alright? But the question is, please be seated. Thank you. Now, we don't have, as of now, we don't have any alternative earth. Okay? This is the only earth, the mother earth, where we are living, we have in our hand. Children, बात में डिस्टर्ब करना, सुनिए, अरे रुचिका, अभी डिस्टर्ब कर रहे हैं, डिस्टर्ब हो रहे हैं. भैया, don't disturb. भैया, hello, भाई साहब, students, don't, you know, let everybody will go. Please be seated. Otherwise they are distracted. All right, few minutes, only 2 minutes I'll take. All right, children, see the question I asked, we don't have any other alternative. This is the only earth we have. This is the only mother earth we have. And God has given so many resources. We have plenty of resources in the earth. But because of our greediness, we exploiting, over-exploit, not exploiting, over-exploiting. As a result of correctly started, we are using all the fuels, fossil fuels, what are the sources, water. So yesterday we went to the river Ganga, the Ganges, and there is huge water flowing. And there are some places, such as Rajasthan and some places in Andhra, somewhere, there water is no water. See, here we are using much and there is no water. People are difficult for harvesting. So this things are happening. So you should not overuse the water which is available with us. So we have more water, we should not waste it. Right? It serves for whom? For future generation. This is important. Sir has covered everything. Now, I am not going to touch on that. Now, I am planning to do, what is the EIACP? This stands for Environment Information, Awareness, Capacity Building and Livelihood Program. The purpose of this is constituted by the Ministry of Environment, Forest and Climate Change. The purpose is to make awareness among the people in our country so that they will use, judiciously they use it, very carefully they use it. You are not saying that don't use it very carefully. Even light, even energy, water, everything, use it very carefully. I'll take 2 examples and I'll complete in 2 minutes. The first, today morning I walked through the campus just for a half an hour walk, myself and Dr. Pankaj. We went through the campus and I was surprised. There is no plastic. For my knowledge, I didn't find any plastic, sir. Principal sir, I didn't find any plastics on the roadside today. That was very good sign. That indicates that you are, maintaining the campus neat and clean. Whatever I've done, there is no plastic. So you should make sure that this is happening. So reduce the single-use plastics wherever you are. Okay? So that will help you to protect it, because the plastic has ended inside the water body now. It's gone to the water, right? So the water ended into water, it will come back to us only through various forms. It may come inside to us. So the plastic pollution is not only for the environmental issue, it is a health issue as well, because it's gone to the water bodies. The water bodies say, tomorrow, someday it will come back to us. We should protect, recycle, come back to us. So it will come, create problem to us, health issues. So we should reduce the water, reduce the plastic, as much as possible. If you are not using plastic, it's well and good. If you are using single-use plastic, very judiciously use it. So what is the alternative? You may ask, what is the alternative? So alternative, use the cloth bags or paper bags, etc. You can use it. You go to shop, you are all youngsters. You are the future of the country. So you go and tell the shop owner when he gives give things in the polythene bag or plastic bag. You tell them, sir, I don't want. I give me a paper bag, or I have my own cloth bag. I will put it here. That's what makes a change. If you make change, your generation will change. Your future, the society will change. So that's what you have to do it. You follow it up. First, plastic. Second, save energy. Now, a couple of days after, that's what Akshay Urja Divas, right? My Hindi is not good. Akshay Urja Divas. That's the unconventional energy day, whatever. All right. So you have to save energy. What are the way you can put for save the energy? How can you save energy? In your school, in your house, and your place, wherever you are there. How will you save energy? Tell me quickly. You. Tell. Quick answer. 3 seconds. Yeah. How you will use it? After using it. All right. Then. Quick. Yeah.
Yes, sir.
Yes, sir. Okay, good. Good. Very nice. So, as you said, see, sometimes we, tend to, because in the house also, AC is on, we will be sitting in some other room, and light will be on, we will be sitting in some other room. So make sure that it starts from small start, it will make a difference, huge difference. Okay? So make wherever you are there, you are all grown up, you are the grown up people, you can able to understand, but it is easy. So you should make that one. One is reduce the single-use plastics, all right? Second, save energy, whatever capacity you have, you are able to do it. Wherever you are there, you can switch off the lights, which is not necessary. Wherever excess water is leaking, you close the tape, whatever. Then it's all energy, you are saving energy, your whatever capacity. So this is what you have to, not only you can tell your parents, you tell your friends, your relatives, so save energy, don't use plastic. That makes, so that will protect, somewhere you are contributing to save the earth for your future generations, right? With that words, I think once again I thank you all for attending this time, and thank you Principal Sir and team for giving the opportunity. Wish you best luck for your future. And as Sir said, our Jawaharlal University is one of the best university in the country, leading university. So you are all welcome whenever you want to come and visit our department, our facilities, our research facilities. You are always welcome. All right. With that word, I thank once again for you. God bless you. Thank you.
You rightly remarked, sir, plastic is the biggest environmental threat today. I would now request Professor Paulraj, EIACP Coordinator, to present a token of his appreciation and love to AECS Narora. I request our Principal Sir, Shri Dilip Singh, to kindly accept the honor. Ma'am, please turn it on. Is it not working?
One more thing we are giving. This is a seed pen. Okay. Inside the refill is the plastic, but we want to reduce the plastic. We have made it. The cover we have made it from that cardboard. And last is behind it is the seeds are there. So when you use it, then after finish you just put it in the soil and the plant will grow. So this is a seed pen. We have tried to reduce the plastic on certain level. So with that, we have one notebook also, and it is made from recycled paper. This notebook, is made from recycled paper. So this we are giving to sir, and these are customized made from JNU only. And one cloth bag. That's what we are saying. That to reduce plastic, one should use the bag. And on this, EICP logo is there. These seed pens, every student, you have received a pouch. Inside there is a seed pen. Okay. And one more thing, we used to publish a calendar every year on environmental. So wherever we used to conduct painting competitions, best 3 paintings, they are reflected in our calendar. It goes all over India and the painting is depicted here with the name of the students. So today only we are conducting a painting competitions and best 3 we will try to convert into a next 2027 calendar which will be circulated all over India to our centers. We have 54 centers all over India. So this is an initiative so that the students should get motivated through this also. Thank you.
Thank you, ma'am.
Next year, your name will be here. This calendar, your name should come. Alright? How many of you want? Your name, this is the names of some school students. Okay, if you see the calendar, some school student's name is written, 8A, 8B, some school's name. Alright? Next year, I want your name should be here. This 12 months, right? So if you do the painting, it reflects here. So that's to ministry as well as all the 54 centers in all over India. Alright? Alright, do well, best of luck.
Thank you, sir and ma'am. Thank you. That is called responsible gifting. And I'm sure all our children will get inspired by these little actions.
So thank you so much for giving this honor. And once again, I would like to share with the students that since now we are beginning our program, you have at least 2 to 3 hours to think over getting input from this program itself, from your already perceived knowledge and experience, what kind of painting you can make for replacement of the fossil fuels with the another kind of alternative fuels. How can you protect environment? How can you protect yourself? So think over it. Keep at the back of your mind that there are so many things which you are going to discuss now. You are going to use immediately after this program. Thank you.
Thank you, sir. May I now request Dr. Ashwini Kumar Tiwari, sir, to give a brief introduction of INYAS-NCR. This will be followed by a lecture on physics and demonstration of Graaff generator by Dr. Pankaj Kumar, sir, and INYAS team.
Good morning, students. So, I am Ashwini Kumar Tiwari. I am Assistant Professor, School of Environmental Science. So, first I would like to thanks to the Principal Sir, Vice Principal Sir, and teachers of the school and staff of the school to giving us opportunity to organize this program. This program is going to be organized with the help of EICP, JNU, and INYAS. So, INYAS is the Indian National Academy of Science. It is the first, unique, and the last. We can say currently we have only one recognized young association only for early career researchers. So who is below the 40 years, they can participate in this program, and the mission of this to promote the science with the young students like you people, okay, to reach out the student and motivate them to opt the science and to the science experiment, and to go for capacity building in the science program. This is our motto. So we always have 100 member one at a time. So every year we induct 20 member for 5 years, and after 5 years 20 member go out. So going to the alumni, like Pankaj sir is our alumni from the INYAS. So I don't want to take much of time. So our motto is to promote you, to motivate you, that your knowledge, your experience, your understanding going to be improved in the field of science, and to provide the opportunity to all across the region of the country. This is our motto. On that motto, we are organizing this event. So, without taking much time, I'd like to thank to everyone to be here and your support. Thank you.
Thank you, sir. And I'm sure this will be followed by some interesting, intriguing demonstration. I request all children to actively participate in the demonstration.
इसको नीचे रखो, माइक को नीचे रखो, वीडियो को इधर साइड करो।
Hello. Okay, so all of you are Gen Z, right? जानते हो ना Gen Z क्या होता है? बताओ क्या होता है? हाँ? All of you are Gen Z, right? क्या होता है Gen Z बताओ? चलो. So the kids who are born after 2014, 13 maybe, all of them, or before, sorry. So it's basically after 2015 it's Gen Alpha, but before that, 2005 till 2015 or 13, they are Gen Z. So all of you are Gen Z, right? So what is special about Gen Z? That they can think faster, they can create better. उनका क्रिएटिव नेचर जो है ना बहुत अच्छा है. तो आप सबका भी क्रिएटिव नेचर अच्छा ही होगा. एनीवे, आप सब लोग यहाँ पे ऑल ऑफ यू आर मे बी नोइंग अबाउट द रिएक्टर्स, राइट? न्यूक्लियर रिएक्टर के बारे में जानते हैं? कौन कौन जानता है न्यूक्लियर रिएक्टर के बारे में? न्यूक्लियर रिएक्टर के बारे में नहीं जानते? बताओ क्या होता है? कहाँ पे है न्यूक्लियर रिएक्टर? अपने आपके आसपास?
In Narora we have
तो न्यूक्लियर रिएक्टर तो सबको पता ही होगा. So nuclear reactor is a device by which you can what? You can do the fission of uranium and then create energy of it. Right? So that is basically nuclear fission. A place, environment under which you can do the nuclear fission. Fission पता है ना सबको पता है? Fission कोर्स नहीं है क्या? मैं तो पता था.
Children, please answer. Nuclear fission. Nobody knows.
Fission is breakdown and fission is like breakdown of atoms for releasing energy and in fusion.
Atom सबको पता हो. Come on.
Smallest building.
कोई और भी बताए. Atom, no atom.
Why did you build up mental?
Elements पता है elements.
Yes.
Periodic table पता है. हाँ. Periodic table में जो है ना. Hydrogen, helium, lithium, और कोई भी एक element है. उसका एक yes and then basically so I am talking about from atoms to archaeology. Archaeology पता है? Archaeology पता है?
का जो माइक है वो इनको दो.
हाँ, archaeology जैसे आप लोग पढ़े होंगे इंडस वैली सिविलाइजेशन. सिंधु घाटी की सभ्यता है ना? तो branch of science where you study the past civilization, है ना? आप सब लोग या हम और आप ऐसे इतने इंटेलिजेंट नहीं थे शुरू में, धीमे धीमे सीखा है. तो आपको पता है जब ह्यूमन रेस वाज इवॉल्व्ड ऑन अर्थ, slowly it acquired the knowledge, it interacted with the environment, and then first of all they were hunter gatherers, so they were just roaming here and there, eating flesh, and now slowly they started living in the colonies in a particular fashion. So that was the civilization long back, and then now we are ultra modern, right? We know how to go on the moon, how to go on Mars. So slowly all these things have come up, but from where we started, that archaeology, Puratatva Vigyan, right? So atom has a power by which you can study the archaeology also. So I will give you a couple of examples. So I represent here INYAS, Indian National Young Academy of Science, which is a society or group of people who promote scientific thinking in the society. How do you think scientifically? But I am scientist at Inter-University Accelerator Center, where we have multiple ion accelerators. But what is ion accelerator? I will tell you. So anyway, this is the building. So here there is an ion accelerator. I will just skip. We have many of them. Around 10 accelerators are there, and this is country's biggest accelerator center, where we have the highest number of accelerators. And these are the photos. So, and these are the experimental stations where we do the experiments. Now, coming, this is the one of the accelerator where there is a ion source, and then here we have a very high voltage, and this is the place where we do the experiment. So, one model of this is here. I will show you this model also. Now, what is accelerator? So, accelerator in daily life also you use. If some of you are riding bike, right? Bike का accelerator दे दिया तो तेज चलने लगी, या फिर साइकिल को थोड़ा जल्दी जल्दी पेडल किया और तेज चलने, दैट्स कॉल्ड एक्सेलरेटर. So acceleration or accelerator is a process by which you can increase the speed, or so this is the examples in the daily life. But I am not talking about this kind of accelerator. We are talking about ion accelerators. So a device which can increase the speed or velocity of ion. You know the difference between the speed and velocity? 12th के कौन कौन है इसमें? 12th क्लास से कौन है? 12वीं? अरे प्राउडली बोलो कि मैं हूं. तो यू नो द डिफरेंस बिटवीन द वेलोसिटी एंड स्पीड? बताओ, आप बताओ. हाँ, आप ही बताओ. चलो. करेक्ट, करेक्ट. बट स्पीड में क्या ऐड कर दो तो ये भी वेलोसिटी बन जाएगी. करेक्ट, बहुत अच्छे. सो आयन एक्सेलरेटर मीन्स द डिवाइस विच कैन इंक्रीज दी क्या velocity of if direction is given. And then how ions can be accelerated? आयन तो सबको पता होगा ना क्या होता है? कोई बात नहीं पता. आयन क्या होता है? Correct. So any neutral atom, if I give charge to it or take charge out of it, it will become ionized. What charge you can give? The most easy thing to give or take is the electron, because electron is the outside. न्यूक्लियस से बाहर है ना. न्यूक्लियस से कुछ निकालोगे तो ब्रेक करना पड़ेगा, उसके लिए तो रिएक्टर चाहिए. रिएक्टर में क्या हो रहा है? फिशन में क्या हुआ था? न्यूक्लियस को ब्रेक कर रहे हो आप, राइट? फिशन, यूरेनियम न्यूक्लियस को ब्रेक ही तो कर रहे हो. बट इलेक्ट्रॉन्स निकालना बहुत इजी है. Even if I rub my hair like this, electrons will transfer. So earlier people, all of our houses has the बड़ा वाला टीवी होता था ना, जो आपके गेस्ट हाउस में वही है अभी भी, CRT वाला. आजकल तो टेलीविजन ये इस तरह की स्क्रीन वाले आ गए, बट पहले बड़ा वाला टीवी होता था. किस किस के घर में बड़ा वाला टीवी? हाँ, तो उसमें भी एक एक्सेलेरेटर होता था. वो बेसिकली क्या है? वेयर एवर यू हैव द इलेक्ट्रिक फील्ड एंड इलेक्ट्रॉन्स को या किसी चार्ज पार्टिकल को आप मूव कर रहे हो जिससे उसकी एनर्जी बढ़ रही है, दैट्स एक्सेलरेटर. सो अर्लियर दिस वाज द स्ट्रक्चर ऑफ आवर टेलीविजन, वेयर वी हैड द इलेक्ट्रॉन एमिटर. एक इलेक्ट्रॉन एमिटर था, फिलामेंट, एंड देन एक्सेलरेशन के लिए यहाँ पे इलेक्ट्रिक फील्ड लगा हुआ था, एंड फोकसिंग के लिए भी एक डिवाइस था. एंड देन ये स्क्रीन जो था वो फास्फोर कोटेड स्क्रीन था. इलेक्ट्रॉन्स विल increase, I mean their energy will be increased and they will be guided and they will fall on the screen and an image can be created. So to increase the energy of ion, you can use the electric voltage or electric field, and to guide them you can use the magnetic field. Now we need to know when any charged particle passes through magnetic field, क्या होता है? हाँ, कौन सा वाला फोर्स लगता है? क्या बोलते हैं उस फोर्स को? नहीं, मैग्नेटिक फील्ड से पास अगर हो रहा है. हाँ, कैसे? हाउ डू यू कैलकुलेट दैट? फॉर्मूला बता दो. वैसे लिखा ही है यहाँ पे, F इक्वल टू QVV sin थीटा. सो यू कैन इंक्रीज द एनर्जी. रिमेंबर ऑलवेज, इफ यू वांट टू इंक्रीज द एनर्जी ऑफ आयंस, यूज द इलेक्ट्रिक फील्ड. And if you want to bend them here and there, you can use the magnetic field. So this is what is there in the accelerator. But why do I need to increase the energy? Why should I do that? क्यों करना है मुझे? Because you know de Broglie equation पढ़ा है? Lambda equal to h upon p. de Broglie equation पढ़ा होगा ना, 12th में है. तो lambda is what? Wavelength. H is Planck constant, P is the momentum. So P is nothing but its mass into velocity. So if I increase the P or increase the velocity, momentum will increase, and by this equation lambda will be less. And resolving power एक होता है. For example, you see with your eyes you see the bigger thing, but if you have to see the smaller things, you require the microscope, right? And then even smaller you require the electron microscope. So you are reducing or increasing reducing the wavelength so that you can see the small things. Anyway, so particle accelerators, ion accelerators are also required to see the small things and also to see inside the nucleus. They can see that. अच्छा, ये मैंने बता दिया आपको what is atom, what is radioisotope. So what is isotope? Isotope पता है आपको क्या होता है? So isotope are basically किसी एलिमेंट के मल्टीपल आइसोटोप्स हो सकते हैं. अगर एटॉमिक नंबर सेम है, मास नंबर अगर डिफरेंट है, दैट इज आइसोटोप. तो कार्बन के 3 आइसोटोप होते हैं, कार्बन 12, कार्बन 13 एंड कार्बन 14. सो कार्बन 12 में क्या होता है? 6 प्रोटॉन, 6 न्यूट्रॉन और 6 इलेक्ट्रॉन. बट कार्बन 13 में 6 प्रोटॉन, 7 न्यूट्रॉन, 6 इलेक्ट्रॉन. एंड कार्बन 14 में क्या होता है? 6 प्रोटॉन, 8 न्यूट्रॉन एंड 6 इलेक्ट्रॉन, राइट? बिकॉज इनका मास चेंज हो रहा है. 12 मास, 13, 14. So 12 and 13 they are stable isotopes. Stable isotope means their concentration is constant. अगर आप 100 एटम्स लोगे 12 कार्बन के, एक जगह रख दो, 100 साल बाद आके भी देखोगे तो 100 के 100 होंगे. लेकिन रेडियोएक्टिव आइसोटोप्स में क्या होता है? दे डिके विद टाइम. उनका डिके होता है, न्यूक्लियर डिके, रेडियोएक्टिव डिके. ये पीरियोडिक टेबल है. तो इसमें हाइड्रोजन है, हीलियम, लिथियम, बेरिलियम, बोरॉन. लेकिन अगर आइसोटोपिक वे में इसको रिप्रेजेंट करेंगे पीरियोडिक टेबल को इन द फॉर्म ऑफ आइसोटोप्स, दैट इज कॉल्ड चार्ट ऑफ न्यूक्लियाइड. सो दिस साइड इज द न्यूट्रॉन नंबर एंड दिस साइड इज द प्रोटॉन नंबर. सो दिस इज न्यूट्रॉन, दिस इज प्रोटॉन. सो हियर you had carbon at one place, but if you plot all of its isotopes, so carbon के इतने सारे isotopes है, but only 3 are common, 12, 13 and 14. Now अगर इस चार्ट ऑफ न्यूक्लियाइड को देखेंगे तो टोटल 80 एलिमेंट हैं जो कि स्टेबल हैं, 38 रेडियोएक्टिव हैं, टोटल 118 है. एंड इसके इनके आइसोटोप्स अगर देखेंगे तो स्टेबल आइसोटोप जो है, स्टेबल आइसोटोप जो है वो 246 है, रेडियोएक्टिव 3000 है एंड टोटल 3349 आइसोटोप्स आते हैं. ऑल दीज रेडियोएक्टिव आइसोटोप्स आर very useful to study the nature. And one of the reason is that they can change their concentration or their number changes with the time. So let us say if some radioactive isotope is there, उसका half life जानते हैं ना? रेडियोएक्टिव आइसोटोप का हाफ लाइफ होता है कि जैसे 100 नंबर है, कितने दिन में 50 हो जाएगा, दैट्स हाफ लाइफ. तो अगर किसी रेडियोएक्टिव आइसोटोप जो कार्बन 14 है उसकी हाफ लाइफ है 5730 ईयर, सो इन 5730 ईयर ये 50% रह जाएगा. अगले हाफ लाइफ में 25% रह जाएगा, उससे अगले हाफ लाइफ में 12.5% रह जाएगा. तो इसका जो डिके होता है दैट इज कॉल्ड एक्सपोनेंशियल डिके. तो अगर 100% है, एक एटम है, फिर आधा ऐसे करके, मतलब परसेंटेज वाइज एटम को ज्यादा नहीं कर सकते. तो कार्बन 14 को हम लोग यूज करते हैं टू स्टडी द नेचर एंड ऑल्सो टू स्टडी to calculate the age of archaeological artifacts. Carbon 14 is very popular because it is the half life is 5730 साल और अपनी सिविलाइजेशन भी लगभग इतने ही साल की है, 5000 साल पुरानी सिविलाइजेशन है. So this is something which is an ideal isotope to study the development of human civilization, and also it is everywhere, is present everywhere. Carbon is in all of us. Like this they will also have the carbon. And so that's how it is very popular. So how this can be used as a dating tool? So as I told you, if let us say at time t equal to 0, it's 10 gram. After one half life, it will become 5 gram, and then 2.5 gram, 1.5 gram, ऐसे चलता रहेगा. अगर आपने ये पता कर लिया कि कितने ग्राम बचा है और कितने एटम बचे हैं, तो आप कैलकुलेट कर सकते हो कि कोई चीज कितना पुरानी है. अच्छा, now question comes up, how 14 carbon is formed? So 14 carbon is formed when the solar radiation comes to earth and it interacts with the nitrogen. 14 carbon is formed, and then 14 carbon interact with this oxygen. CO2 is formed, and then CO2 is eaten up or taken up by plant in photosynthesis. Photosynthesis process में क्या होता है? CO2 लेते हैं प्लांट एंड ऑक्सीजन छोड़ते हैं. तो कार्बन इनके अंदर रह जाता है. तो कार्बन 12 भी है, 13 भी है, 14 भी है. As long as this plant is alive, फोटोसिंथेसिस करता रहेगा. जैसे ही प्लांट मर जाता है तो 14 कार्बन आना बंद हो जाता है उसके अंदर. So by measuring the 14 carbon number of 14 carbon atoms, you can calculate when this plant became dead. So that's called radiocarbon dating. And the same thing can be applied for human, for good artifacts, and all of these things can be dated. I will give you some of the example. This is the archaeology people are there. They have found a human body skeleton. So plant, हम लोग प्लांट खाते हैं, हम लोग प्लांट बेस्ड डाइट है ना हमारा, राइट? वीट खाते हैं, वो भी प्लांट से आता है. तो हमारे अंदर भी 14 कार्बन लेवल रहता है. When the humans are also dead, उनका भी 14 कार्बन सप्लाई बंद हो जाता है. So by measuring the 14 carbon number, you can calculate when this person became dead. So this is one of the archaeological site where the human almost highly preserved human skeleton is taken out, and then we take a small piece of bone, and then there we measure using accelerator. There we measure how many carbon 14 atoms are left in it, and then we can calculate the age. And without knowing age, there is no point. You cannot tell that this particular human skeleton belongs to which civilization or which time period, right? So chronology is important. So this is the picture from the one of the archaeological site called Dholavira, and this is the script. This is still a challenge. Nobody till now has been able to read what is written by our ancestors. ये इंडस वैली स्क्रिप्ट है, ये अभी पढ़ने में नहीं आई है. लोग पीपल आर ट्राइंग, बट नोबडी हैज डेसिफर्ड इट. मतलब दे कैन नॉट रीड व्हाट इज रिटन, एंड many of the things written in this kind of symbols is available. If you can read it, if you can decipher कि ये क्या लिखा है, तो आपको नोबेल प्राइज मिलना पक्का है. I can tell you this. This is a big challenge. It's still a question which people are trying to solve. Anyway, so then now I will give you some exciting examples of radiocarbon dating. तो एक ये जगह है इटली और ऑस्ट्रिया के बॉर्डर पे, that's called Alps पे है. So there were two hikers and they saw a human body half covered in the ice, half it was exposed. So then they took it out, and later on with computer his image was formed later on. But this is a big subject on which many people are working. So first of all, people tried to know how old it is, how old this body, whether it is very recent or whether it's very old. So it was dated, a small piece of his shoes. Shoes was made up of leather. Leather is what? Animal product. Animal will eat grass or plants. So 14 carbon will go in his body also, animal's body. And then it was dated and it came out, it's around 5300 years old. 5300 साल पुराना था. So ये एज मिला, एज मिलने के बाद then this body is kept in a museum where lot of studies are being done. What studies are being done? In his stomach, because it was buried in ice, बर्फ में था, तो उससे क्या हुआ कि इसका बॉडी पूरा प्रिजर्व रहा, है ना, डिकम्पोज नहीं हुआ. तो इन हिज स्टमक देयर वाज सम अनडाइजेस्टेड फूड आल्सो. सो दैट वाज स्टडीड कि क्या खाते थे उस 5300 साल पहले लोग क्या खाते थे, किस तरह का बॉडी से जो क्लोथ्स वगैरह मिले उससे किस तरह का रहन सहन था, वो सारी स्टडी चल रही है. दिस इज वन ऑफ द एग्जाम्पल. Another example is in Italy, once again, there is a place called Turin. Turin में there is a cloth which is 14 feet by 3.4 feet dimension. A cloth is kept, and if you see closely, आपको दिख रहा होगा यहाँ पे एक ह्यूमन बॉडी, ह्यूमन फेस है, ये दो हाथ है. So it's something like this. So something like this. So it is believed in people, local people there, they believe that this is the cloth by which Jesus Christ, when he was crucified, after that his body was covered with this cloth. So that's why it is called Shroud of Turin. And then, science can bring out the truth, right? So then, AMS laboratory or these people who do the dating, they approached Vatican. Vatican, is the highest authority of Catholic Christian. They approached that whether we can get only one thread, सिर्फ एक धागा चाहिए इसमें से, because it's matter of religious belief, so it's not easy to take sample out of it. So a small thread, 3 threads were taken and they were sent to 3 different laboratories for dating, and the date came out 1353 AD, right? अगर जीसस क्राइस्ट की बॉडी से कवर की गई होती तो ये कितना पुराना आता, 2025, जैसे आज की डेट में अगर देखें, बिकॉज द कैलेंडर स्टार्ट्स फ्रॉम दैट ना 2025. But it was 1353 AD only. And there is a very good YouTube video, and this paper was published in Nature. And so science can tell you the truth. And then there are a lot of other examples. I don't have so much time because I have to show you this accelerator also. So I will stop it here. I come back. Well, this is the actual accelerator, and this is the model, and now we will experience how using a 220 volt power, 220 volt है ना अपना जो AC power, you can generate thousands of volt potential, right? तो जैसे 220 से आप 10 किलो वोल्ट भी जनरेट कर सकते हैं, और हम लोग इसमें 15 मेगा वोल्ट जनरेट करते हैं. मेगा समझते हैं ना क्या होता है? हाँ, 10⁶. अगर इस बिजली को छू लो तो क्या होगा? करंट लगेगा ना. वी आर डीलिंग विथ 15 million volt, and on this day I invite all of you, principal sir, if you can arrange their visit, we will be happy to have a program where we invite school students to visit our laboratory and they see themselves what is going on in these national laboratories. So we can come, we can only give you flavor, but if you come there, spend one day, you can see with your own eyes, you can see how things are. Probably in the reactor you may not go because it may not be allowed for kids to go inside, but in our laboratory it's controlled radiation, it's allowed. I mean, there is no harm. So, now we will see this. This model is called Bandy Graaff generator. So first such kind of accelerator was developed by a scientist called Bandy Graaff, and on his name, this is called Bandy Graaff generator. So what happens here? Here there is a there is a motor which rotates a belt. In this case, it's a chain, but here you have a belt. This belt is there. It is rotated, and at the bottom, this belt is in contact with a aluminium, kind of form. So what happens that when you do the friction of two things, and one is the plastic, one is the metal, then what will happen? The electron, the belt will carry the positive charge. Electrons will go towards the metal, and this positive charge, finally they are in contact with the dome. ये भगोना टाइप का देख रहे हो ना आप भगोना ही बोलते हैं ना so the charge, so in the 12th class you will read it. So let's say if you have a sphere, even if you give charge at the center, and it will go on the surface. So all the charge, positive charge will come on the surface. Now how do you know whether positive charge is there or not? So that can be demonstrated by certain experiments. कार्बन डेटिंग में सैंपल प्रिपरेशन रहता है because you will have to target the carbon which is old carbon, not the recent carbon. So that has to undergo some kind of chemical and physical, mostly small chemistry steps. You have to wash the sample with the acid and then NaOH and then again with the acid. It varies from sample type to sample type. Right. Depending on its age, yeah, and availability. Oh, carbon is good if it is there. हाँ, 10 year है उसके लिए कुछ और आइसोटोप यूज होगा. 10 million year है because carbon, any this radioactive isotope clock that can work up to 10 half-life. Half-life multiplied by 10. So carbon half-life is around 5,700 years. So you can go back around 50,000 easily. Yes, selection of isotope is done on the basis of age and on the basis of availability of that particular isotope in the sample. Yeah. So let's say if you want to calculate the age of Earth when the Earth was formed, you cannot use carbon. You will have to use some other. So we use uranium and its decay product finally lead. So uranium lead inside a crystal, which was once upon opened during the formation of Earth, and then it's closed. So inside the mineral, you see the uranium and lead isotopes.
We can discuss later.
Yeah, because science. Okay. तो मैंने आपको बताया कि चार्ज इस बेल्ट के थ्रू आ रहा है एंड यहाँ पे एक तार लगा हुआ है. ये तार फाइनली इससे कनेक्टेड है एंड ये यहाँ पे कनेक्ट हो जाता है तो इसके ऊपर चार्ज आ जाएगा. करके देखते हैं. अच्छा, हाँ ठीक है. तो वो रोटेट कर रही है.